Hello my dear students, welcome to IMS Academy GATE Foundation course on Network Theory subject. So this is the first session regarding Network Theory subject regarding GATE Foundation course. This particular subject is common for three branches: EC, Electrical and Instrumentation. So all of you kindly share this video link with all of your friends so that they also will get benefited from this particular session, right? So I hope all of you will share this particular video link with all of your friends quickly. Okay, whoever watching regarding this particular live session very first time at our IMS GATE Academy, so all of you kindly subscribe. Okay, so all of you like this particular video and all of you kindly share this video link with all of your friends so that they also will get benefited from this particular session, because in this foundation series we are discussing the concepts at very basic level, right? So whoever want to start their GATE preparation, whoever aspiring for the GATE 2025 or 2026, right? For all the aspirants, whoever want to start their GATE preparation, so for all the beginners, this particular session regarding network theory subject is going to help a lot. Okay, so before going to start the today's session, I am going to give two important updates for all of you. So the first one is regarding our IMS GATE Academy Telegram channel. So whoever not yet joined, so kindly all of you join our Telegram channel. It is free for everyone, right? So regarding this particular link already provided in the description of this particular video. Okay, so whoever join our Telegram channel, what are the benefits that you people are getting? Say for example, currently one live session is happening at our IMS GATE Academy YouTube channel, right? So like this, whenever upcoming live events are there, live sessions are there, all the updates you will be getting in this particular Telegram channel, and especially whenever regarding the class. Okay, so whatever faculty might have written on the digital board, right after the class over, whatever faculty might have written on the digital board, that particular notes we will be sharing in the PDF form. That particular PDF we will be sharing in this particular Telegram channel, right? And whenever there are the webinars, okay, so you will get all the important updates related to webinars and even regarding government job notifications. And on daily basis in this Telegram channel, our faculties used to post one quiz question, right? So all of you kindly actively participate in that quiz. You are getting one opportunity on daily basis. You are learning one question, okay? And the very next day our faculty will provide the solution. You can go through that solution and your knowledge you can update on daily basis, okay? So this is one of the important update. I hope all of you will join our Telegram channel, whoever not yet joined till now. Okay. And one more important update, and this particular update is very much helpful for all the GATE aspirants of 25 and 26. At our IMS GATE Academy, we are having the live online program, right? So whoever, like in the GATE 2024, whoever expected, who are supposed to get very good marks in the 2024, but somehow they couldn't get, okay, even those students, okay, they can continue their GATE preparation, and even whoever targeting for 25 or 26, all the students, okay, so whoever interested, okay, so all the students can click on the for free counseling session regarding this particular session link already provided in the description of this particular video, and even you can call to these two numbers, any of these two numbers. Our counselors will discuss the complete details about this live online program, right? So here for the time being I am discussing the features of this live online program briefly. So whoever enrolling for our live online program, all the students are able to get 800 plus hours of live online classes, okay? And here in the live online classes, all our faculties will discuss each and every concept from the basic level to the application level, and our faculties will discuss for every concept the variety of questions, okay? So the exercise book questions we will be discussing, and the GATE questions also we will be discussing in order to cover all the variety of questions, okay? In the live classes our faculties will discuss, okay? And in addition to that, for all the enrolled students, for every subject we are going to provide theory book and we are going to provide exercise book. So branch wise if you consider, okay, all the exercise book questions together you will be having 4,000 plus questions, okay? These number of questions are more than sufficient whoever want to target for GATE 25-26, okay? So in our exercise book we are having for every chapter 3 levels of questions, like level 1, level 2, level 3. In each level there will be 20 questions, right? So all the students who are practicing exercise book questions, they are getting good command over the concepts. And not only that, in addition to theory book, exercise book, we are going to provide the GATE question bank, which consists of last 34 plus years, right? So with the help of this GATE question bank, all the students who are enrolling at our live online program, they will get great learning. Okay, so here wherever required, we have provided alternate solution, and even for typical questions, our faculties have provided the video solutions. You people have to scan the QR code, which is QR scanner, which is available in your mobile. With the help of that, you can scan the QR code, then our respective faculties video solution will be played. You can get the complete information, right? And in addition to that, at our IMS Gate Academy, we are providing 12 My Plan sessions for all the enrolled students, right? So all the students, they can get one My Plan session with the corresponding mentor, so that they can get the proper guidance and study plan. It will be very much helpful for their success in the GATE 25-26. And in addition to that, we are providing 130 plus online tests at our IMS Gate Academy, which includes for every chapter there will be one test, that is called chapter test. Similarly, for every subject we are having basic level test, advanced level test, and then multi-subject test also we are having. And after that we are having all the mock tests as well. So all together we are having 130 plus online tests. So whoever targeting for 25 and 26, whoever want to get very good rank in the upcoming years, so here at our IMS Gate Academy, we are providing each and everything whatever required for the students whoever want to get success in the upcoming years, right? So all of you kindly share this valuable information, okay, especially whoever targeting for upcoming years 25, 26, okay, right? So I hope all of you are eagerly waiting for today's session. So let us start. Yeah, good evening, Matan. Yeah, so all of you put the heading Introduction to Network Theory subject. So this is the first session regarding network theory subject regarding foundation course at our IMS Gate Academy. Okay, so this subject, as I mentioned earlier, this subject is common for 3 branches: EC, electrical and instrumentation. This is one of the basic subject and scoring subject as for GATE exam point of view for all the 3 branches: EC, electrical and instrumentation. Okay, so before going to the details of this particular subject, okay, I am just asking one simple question. So all of you can answer in the chart. All of you read this question and mention your answer in the chart. Can you give few examples of networks that we are using in our daily life? All of you can mention. So in our daily life, we are using so many networks, okay. So whatever the networks you might have observed or you might be using, can you give few names regarding the networks? Yes, just observe here. Just observe this slide. What is your observation? Here we have connected computers or laptops, right? So that means you can call this network as computer network. Computer network, or even you can call internet or networking. Right? Okay, similarly you can observe this one. Here various mobiles are interconnected, or here one person to another person, the communication is happening with the help of mobile, right? Mobile communication or cellular communication, right? So here you can call it as mobile network. Mobile network or cellular network. Okay, I hope all of you are using, right? Nowadays, all of you are using smartphones, okay? So I hope this slide, all of you are very much familiar, right? So nowadays, we are having various social networking, right, apps and all. So you people might be using Facebook or WhatsApp, Instagram, Messenger, etc., right? So all these are social networks, right? So here, if you observe whatever the networks I have shown, the first slide is computer network, or the second slide is regarding mobile network, or the third one even social networking, right? So if you observe all the three, what is the common point? Any guess? I have used the term network, okay? In all the three slides, I have used the term network. So what is the common point in all the three? Yes, very good, connecting, right? Connecting. So here, if you observe, computer network means we are connecting computers or laptops, right? Whereas mobile network means we are connecting the mobiles, okay? Whereas the social networking, if you observe, we are connecting the people, yes or no? Even with the help of mobile communication or cellular communication or even computer network, ultimately with the help of internet or any other platform, we are connecting the people, yes or no? Hi Abhi, good evening. Okay, so here the common point among all the networks is connection or interconnecting, right? So with this understanding, now you can write the definition of network. Okay, so network is nothing but interconnection of components. Network is nothing but interconnection of components, okay, right? So similarly, in that network, whatever the components that you are using, if those components are of electrical type, then we can call that network as electrical network, okay? So write down the definition regarding electrical network. Electrical network is an interconnection of electrical components. Is an interconnection of electrical components, okay? So now with this understanding, can anyone guess what is electrical circuit? All of you can answer. What is electrical circuit? Any guess? Up to now we have introduced the term regarding network. Now I am introducing the term circuit. Any guess? What do you mean by circuit? Or what do you mean by electrical circuit or electric circuit? Just mention in simple words in the chart. What is circuit? Yes. See, electric circuit is nothing but whatever the electric network we have told. Okay, it is same thing, but in that network you should have at least one closed path. Then we can say that network as circuit. Okay. Circuit means whenever you are telling the word circuit, that means there should be closed path. Okay. So you can write down the definition regarding electrical circuit. Electrical circuit is nothing but electrical circuit is nothing but electrical network which contains at least one closed path, which contains at least one closed path. So this is the must and should condition. Okay, whatever the electrical network you have considered, in that network, if there is the at least one closed path, then we can call that network as circuit. Okay. So I hope all of you might have used, okay, in your daily life, okay, at some point of time, whenever, especially night time or even in the daytime, whenever there is a dark room, okay, you people might have used the torchlight, right? So just observe this torchlight. What are the three main components you are having? Any guess? Already you are having the diagram. At least from the diagram also you can guess. What are the three main components you are having? Abhi, Matan, other students also can mention. What are the three main components are there in torchlight? Yes, obviously you can observe here. Here you are having battery. Yes or no? Here you are having battery. So battery is the first component or one of the main component. Okay, here we have used two batteries. Okay, so for the time we have written like singular battery. Okay, and here you are having sliding switch. Okay, sliding switch you are having. And then you are having the bulb. So these are the three main components that are there inside the torchlight. Yes sir? Okay. See, ultimate purpose is what? You are having the battery, you are having the bulb. Okay. Whenever there is a requirement, so with the help of this sliding switch, say for example, if you are making the switch towards right hand side, that means you are connecting the battery to the bulb. That means there is a closed path, then because of that the current will flow and the bulb will be on. Okay, so that means whenever with the help of this sliding switch, okay, if you are making the direction towards right hand side, that means you can say that the switch is in the closed position. So whenever the switch is in the closed position, that time bulb is on. That time bulb is on. Okay, so that particular circuit we are calling it as closed circuit. Closed circuit. Okay, suppose whenever you don't want, okay, the bulb to on, okay, so that time you are making the sliding switch direction, you are moving the switch towards the other side. Okay, so that time you are opening the switch. Yes or no? The switch is in the open position. So that means you are disconnecting the battery and bulb, right? So that means there is no connection between the battery and bulb. So that means it is an open circuit. In that case, there is no current flow in the circuit, right? So bulb will be off. So in this case, we can call it as open circuit. Okay, so here with the help of switch, whenever there is a requirement, we are connecting the battery and bulb. Whenever we don't want, that time we are disconnecting the battery and bulb. Okay, so in this way, with the help of switch, when it is closed position, we are calling it as closed circuit. When it is in open position, we are calling it as open circuit. Now if you observe, earlier the definition wise, when you have observed regarding electric circuit, what I have mentioned, whatever the electric network you are having, in that network, if you are having at least one closed path, then only we can call that network as circuit. Yes or no? So with respect to that, here when you are making the switch position towards right hand side, then because of that battery and bulb are connected, so in that case the bulb on, so that is a circuit. Now what about other case? With the help of sliding switch, when we have made the direction, when we moved it towards opposite side, then we are disconnecting the battery and bulb. Okay, that time the bulb is off, but still we are calling it as circuit. But in front of circuit, I have put one name like open. Okay, so why we are calling it as circuit still? Any guess? See, in the first case, I am calling it as circuit, there is no problem because you are having closed path. In the closed path, current flows. Okay, but what about in other case? Why I am calling still as a circuit? Any guess? This is very interesting. Yeah, you can observe here. See, you are having one room. Okay, so here you can observe 4 sides you are having walls. Okay, and top you are having ceiling. Okay, suppose here you can consider this door is like switch. Okay, say for example, all the 4 sides only walls are there, there is no door. There is no door. Is there any use of that room? Since all the 4 sides are closed, okay, so that is like closed room. Okay, if you want, you can use as a store room. Okay, but one time only you can use, because whenever you want to use that room later, you have to break the wall, right? So that means in the real sense, okay, in the practical application, if you are having all the 4 sides walls and if there is no door, there is no use of that particular room. Okay, but here you can observe with the help of this door, what is happening? Okay, say for example, when the door is closed, then we are calling that room is closed room. When the door is open, we are calling it as open room. Okay, so that means here the door is required. Okay, whenever you want to enter inside the room, that time you will open the door. Okay, after that, after entering the room, if you want to lock it or if you want to close, okay, then you can close the door. Like that, here the purpose of switch is whenever you want bulb to be on, that time you are making the switch direction or switch you are making towards right hand side or you are shifting towards right hand side. Okay, whenever you don't want, that time you are making the switch position towards other side, so that means you are disconnecting the battery and bulb. So in this way, in the real time application, the switch is required. Here the intention of using switch is the main purpose. Whenever there is a requirement, that time we are making the closed path. Whenever we don't want, that time we are disconnecting. That time we are disconnecting the battery and bulb. I hope all of you are getting the clarity. Okay, so analogy point of view, I have given the room. Okay, room with door. Okay, that like that you can consider. That's why here we have mentioned it is closed circuit and then open circuit. Okay, I hope all of you are getting the clarity. Now with this understanding, all of you just give a try. This is the MSQ question. Either one option or more than one option can be correct. So whatever so far in this particular session regarding the terminology regarding network and circuit, based on that all of you can mention whatever possible options you feel correct, you can mention in the chart. So there is no negative marking, right? So regarding MSQ in the GATE exam, there is no negative marking, there is no partial marking. Okay, since all of you are attending live classes, you are learning the subject, right? So here also there is no negative marking. All of you can mention whatever the options you feel correct, you can mention. Okay, if you are getting wrong, no issue. Later while I am explaining, you can get correct wherever you have done mistake, no issue. Yes, Sajay. Current is nothing but the time rate of flow of charge, dq by dt. All of you just give it a try. This is a very interesting question. Whatever the options you feel correct, you can mention in the chart. Yes, Ajay. If it is a continuous, you can perform the differentiation. If it is like discrete case, then you can use the other formula. Both will give similar one only. Like if you are considering 2 points, okay, the corresponding at 2 time instants, if you are having corresponding charges, then accordingly you can consider the difference. Okay. Okay, based on the waveform, you can consider accordingly. If the waveform is like regarding the charge, okay, if it is like continuous, then accordingly you can consider the first formula. If it is like discrete, then you can consider the second formula. But mostly we will be using the first formula only. Okay, whenever you see any competitive exam questions, you'll be having the waveform, okay, it will be in the continuous manner. Okay, right. So here you can observe, choose the correct option or options. Choose the correct option or options. Okay. So all electrical circuits are electrical networks. Whether this statement is correct or not. All electrical circuits are electrical networks. Yes. All electrical circuits by default all electrical circuits are electrical networks. If you recall the basic definition, what we have mentioned, electric circuit is nothing but electrical network, okay, so which contains at least one closed path. So that means electric circuits are nothing but electric network only. Okay. Next one, all electrical networks need not be electric circuits. Yes, this is also correct. See, in that electrical network, if there is no closed path, then we will call simply as a network. But in that network, if you are having at least one closed path, then we are calling that network as circuit. That means you can observe here, all electric circuits by default electrical networks, but all electric networks need not be electric circuits. Okay, so both are correct. Now all of you just give a try, because out of 4 choices as of now we are able to identify A and B are correct. So just by observing C and D, which option you want to eliminate? All of you give a try. One option you can eliminate. I have given the hint. Yeah. See here, electric circuit is subset of electric network. Whether this is correct? Yes, obviously this is correct. Obviously the last one, when you read electrical network is subset of electric circuit, that is wrong. So for this question, only 3 choices are correct, A, B and C. A, B and C, 3 options are correct. Okay, so regarding the third statement, option C, okay, so in order to get more clarity, I am showing the next slide. With the help of this slide, you will get the clarity. Say for example, earlier torchlight, whatever the example we have considered, that is like one circuit. In a similar way, you can consider one room. One room you can consider like circuit. Okay. Similarly, when you are having a apartment or building, right? So in that apartment or building, you will be having number of floors, right? Number of floors you will be having. In every floor, you will be having number of rooms, right? So you can consider building is nothing but network, okay, whereas room is nothing but circuit. So that means electric circuit is subset of electric network, right? So just observe, electric circuit is subset of electric network. Okay, right. Yeah, thank you, Gopal. So with the help of this analogy, okay, you people can answer the difference between circuit and network during the interview. Okay, while you are learning this particular subject or while you are studying with respect to BTech or GATE exam point of view, you can use the words circuit and network like synonymous. But as for interview point of view, there is a slight difference between circuit and network. I hope all of you got the clarity between the circuit and network. Okay, so with that understanding, now let us move on. So for the time being, I am considering electric network. I am representing as single box. Okay. Say for example, you are having electrical network, okay, which consists of various electrical components. Okay, so for that physical network, okay, you are giving some set of inputs and you are analyzing what kind of output that you are going to get. Say for example, in your laboratory, you are doing some experiment, okay, regarding the electrical networks. You are giving some test inputs, okay, from the function generator. You may be generating some standard test signals. That standard test signals you are giving as input, and based on that you are analyzing what kind of output you are going to get. Okay, so this is called analysis. This is called analysis. You are analyzing the kind of output that you are going to get, or whether you are getting your desired output or not. Okay, so that means you are having the network or circuit, you are giving the inputs, you are analyzing the outputs. That is called network analysis. Okay, similarly, if you are considering the name circuit, accordingly we will call it as circuit analysis. Okay, right. Whereas network synthesis. So in this case, you don't have physically network with you. Okay, you have to design it. Okay, but you know what kind of output you are expecting, or what are your desired outputs that you know, and whatever the standard test signals available, that also you know. So that means you know, you are having the knowledge about the corresponding inputs and outputs, but you have to design the circuit. Okay, so then in that case, that circuit or network, if you are designing, that is called network synthesis or circuit synthesis accordingly. So in this case, electrical network is not directly available, but you have to design. So I hope all of you are getting the clarity between the words analysis and synthesis. Analysis means the network physically available. Okay, whatever the electrical network or electrical circuit you are having, that is there available. Okay, you are given the inputs and you are analyzing the output. That is called analysis. Whereas synthesis means physically the network is not available, that you have to design based on the requirement. Okay, whatever the standard output that you are expecting, okay, with the help of standard inputs, based on that you have to design this particular network or circuit. Then we will call it as network synthesis or network design. Okay, say for example, in this introduction subject like network theory, so you will be learning about various passive elements like resistors, inductors and capacitors. Okay, in this introduction subject or the basic subject, you are going to study the behavior of each and every component with respect to resistor, inductor, capacitor in terms of voltage and current. Okay, once if you study and understand the behavior of each and every electrical component, then later whenever if you want to design a circuit or system with the help of combination of these elements, like say for example with the help of resistors and capacitors or inductors and capacitors or resistors, inductors and capacitors, etc., you can design say for example if you want to design filters, you can design. If you want to design oscillators, you can design. Okay, so regarding filters, of course you will be learning in this subject also, but more applications are the sort of circuits that you will be learning in another subject. Can you recall regarding filters and oscillators which subject you are going to study? All of you can mention. Regarding filters and oscillators, in which subject you are going to study? Yes, you will be studying in the analog circuit subject, right? Analog circuit subject. Okay, so whatever the concepts you are studying in the network theory subject, that is going to help while you are studying the application subjects like analog circuits. Okay, so regarding gate exam point of view, regarding network theory subject, the weightage will be there for all the three branches, EC, electrical, IN. It will be around 8 marks. Okay, but it is like whatever the methods or theorems that you are going to study in network theory subject, okay, while you are solving the analog circuits, equivalent circuits, okay, that time you will be applying, okay, whatever the concepts you might have studied in the network theory subject, you will be applying. So that means indirectly it is helping to score more than 8 marks. I can say easily with the help of, if you are good at network theory subject, you can easily score around 12 marks in the gate exam. Okay, so that much importance is there regarding network theory subject. That's why in the foundation course, okay, at our IMS Gate Academy, okay, we are teaching the basic concepts of network theory subject. So that means that to first chapter only. Okay, so since today is the first session, okay, so in this particular session and in the upcoming days, okay, I will be discussing various types of elements, okay, and we will be discussing whatever the concepts are there. Regarding those concepts, I will discuss the basic level questions, and then level of difficulty also I will increase, so that all of you will get good command over the types of network elements. And regarding those network elements, whatever the formulas involved, okay, and formula based questions also you will be getting. And after that we will be discussing basic laws. Regarding that basic laws also, regarding that also we will be discussing concept wise and variety of questions also, so that all of you will get complete picture regarding the basics. Once basics are strong, no matter when you are learning the concepts of upcoming chapters, definitely you people can correlate and you can perform well. Suppose if your basics are not strong, then no matter whatever the concept you might be studying in this subject or whatever the concept you might be studying in the application subject, then definitely you will be having some partial knowledge you may be getting, but full-fledged knowledge you are not getting. If you want to get full-fledged knowledge in every subject, so you should be fundamentally strong. That is the reason in our YouTube channel regarding network theory subject, we are having series of lectures. Okay, so today is the first session. So in this series of lectures, I am going to cover two important topics. One is network elements and then basic laws. Okay, I hope it is clear for everyone regarding the agenda of our foundation course on network theory subject at our IMS Gate Academy. Okay, right. So all of you put the heading types of network elements. Okay, I hope all of you are having some basic knowledge. So can any of you can mention in the chart what are the various types of network elements we are having? So some of you might have studied regarding the types of signals or types of systems, etc. Okay, in other subjects. So with the help of that knowledge also, at least some terminology you can guess. Yes, all of you put the heading types of network elements. So the first one is active and passive. Second one is linear and non-linear. Third one, anyone can guess. I have mentioned two classification, active and passive, linear and non-linear. Yes, bilateral and unilateral. Bilateral and unilateral. And the next one is lumped and distributed. Lumped and distributed. So in this way, whatever the network elements we are having, we can do the classification. Okay. Now let us study one by one. Okay. So in this particular session, I am going to introduce the terminology. Okay. And in the next session that we will be having on tomorrow, in that session, from the given characteristics, we will be identifying whether it is active or passive, linear or non-linear, bilateral or unilateral. Okay. Right. So all of you just give a try. All of you just read these two lines. Okay, what word you will fill here, what word you will fill here. All of you can mention the chart. See here, an element is said to be dash if it delivers net amount of energy. So from that word only you can guess. It is delivering energy. Whenever any element delivers energy, that particular element we will call it as active element. Active element. An element is said to be active if it delivers net amount of energy. Otherwise, it is said to be passive. Otherwise, it is said to be passive. Okay, right. Now, all of you just give a try. This is an MSQ question. You are having 4 choices. So among these 4 choices, which options you are having passive elements? Either one option or more than one option can be correct. So this is a simple question. I hope all of you can answer. Yeah, you can observe here, even in the torch light, when we have considered the circuit diagram, there you are having battery. Okay, so in that you can observe that the battery delivers the energy. So that means it is the active element. Battery is the active element. Battery is the active element, or we can say battery is an example of active element. Okay, whereas resistor, inductor, capacitor, these 3 are the passive elements. Okay. So these 3 elements absorb the energy, right? So that's why these are the examples of passive elements. So option B, option C, option D are the correct answers for this question. Okay, right. So all of you give a try. All of you just read the sentences and fill the blanks. All of you give a try. Yes, very good. What is your name? Yeah, options B, C, D are correct for the previous question. What is your name? Yes, very good, very good. An element is said to be dash if for all time t its characteristics is a straight line passing through origin, right? Whenever you are having the characteristics, if the characteristics is a straight line and passing through the origin, that means it is a linear. Very good. Otherwise it is said to be non-linear. I hope all of you familiar when you have studied regarding mathematics in the school standard or intermediate standard, you might have studied one straight line equation passing through the origin. What is the equation? Can anyone recall the equation of straight line passing through origin? Y equal to mx, right? Y equal to mx. Y equal to mx is a straight line equation. That line is passing through origin. So that means it is a linear. Okay, like that, if you are getting the voltage and current characteristics or any two quantities regarding that particular element with respect to output and input, when you draw the characteristics, if the characteristics is a straight line passing through origin, then we will call it as linear. Otherwise, that element we will call it as non-linear. Okay. Similarly, all of you give a try. Just read the questions and fill the blanks. Just read the sentences and fill the blanks. An element is said to be dash if it offers same impedance. This is very, very important. If it offers same impedance for different directions of current flow. Otherwise, it is said to be dash. So from here you can catch. For different directions of current flow, okay, if it offers same impedance, that means it is bilateral. Otherwise, it is said to be unilateral. Otherwise, it is said to be unilateral. Say for example, okay, say for example, you are having one element. Okay. So for the timing, I am labeling you are having terminal 1 and terminal 2. Two terminals you are having. Any electrical component, whatever the electrical components that you will be studying in this entire subject, so you will be having two terminals. Okay. So say for example, if the voltage across terminal 1 and 2, you are having the voltage V, polarity is plus minus like this, then all of you please respond, the current will flow from terminal 1 to 2 or terminal 2 to 1. All of you just give a try. See here you can observe, here you are having voltage polarity plus, here minus. Okay. So just you can consider analogous point of view, the current is nothing but just like water flow. Water, how it flows, from where to where it will flow, always from high level to the low level, right? So in a similar way, the current flows from high potential to the low potential, right? So with respect to that sense, you can consider like this. Okay, current flows from terminal 1 to 2 because at terminal 1 you are having high voltage when compared to terminal 2, or based on the polarities you can observe. Okay, whereas in the second case, okay, if you want you can consider this like figure A or case 1, and this is figure B or case 2. Okay, so in this case what I have done, see whatever the electrical component I have considered, I have kept as it is. Terminal 1 to 2, I have kept the electrical component as it is. I not disturb the terminals. But what I have done, in the case 1, I have applied positive polarity here and negative polarity here. Whereas here, I have put volta. Okay. At second terminal, I have given positive polarity. At first terminal, I have given negative polarity. Okay. So because you are having plus sign here and minus sign here with respect to voltage polarities. In this case, the current will flow from terminal 2 to terminal 1. That's all. Okay. Now just consider with respect to terminal 1 and 2. With respect to terminal 1 and 2, I am considering, okay, between 1 and 2, you are having the voltage V. You are having the voltage V. And between 1 and 2, the current I is flowing like this. The current I is flowing like this. Okay. So you are taking the ratio of voltage and current. That is nothing but what? Impedance. This is the case 1. Case 1. Now case 2, see, whatever the terminals 1 and 2 I have considered, with respect to 1 and 2 only I am analyzing. Okay. But just observe here. Here plus and minus. So voltage I have considered plus V. If you want more clearly, you can mention like this. Plus V plus I. Okay. Now with respect to terminals 1 and 2. With respect to terminals 1 and 2, I am having minus V. I am having minus V. Okay. And just observe. Here actually current is flowing like this. I current is flowing like this. But my induction is what? With respect to terminal 1 and 2. 1 and 2. So that means in this direction how much current is flowing? Can anyone mention in the chart? From terminal 1 to 2, how much current is flowing? Any guess? It is very simple. I hope all of you can answer. See, in this direction, if 5 ampere current is flowing, in the opposite way, minus 5 ampere is flowing. So, since here I current is flowing, in the opposite direction, minus I is flowing. Minus I is flowing. So, here minus will get cancelled. You are getting V by I. V by I. So, that means in case 1, whatever the ratio of voltage and current you got, in case 2 also you got like that. If you are getting like that, whatever the electrical component, if the ratio of output and input, the value is constant, okay, then we can call that particular element or component as bilateral. Bilateral. Here lateral means direction. That direction refers to what? Current direction. Okay. So that means in case 1 the current is flowing like this, whereas in case 2 the current is flowing in the opposite way. Or in other words, you can consider because of voltage polarity plus here minus here, the current is flowing like this. Now we have changed the polarities of voltage. Because of that the current direction is changing. Okay. Whether current is flowing in this direction or whether current is flowing in this direction, ultimately the ratio of voltage and current with respect to terminal 1 and 2, in both the cases it is same. That's why this is an example of bilateral. Now you can observe, since we are taking the ratio of voltage and current, that is nothing but impedance. Okay. If you are considering like only resistor, you can consider voltage and current ratio is nothing but resistor. But as I mentioned, along with resistor, you may be having inductor or you may be having capacitor individually, or maybe combination of resistor and inductor, or maybe combination of resistor and capacitor, or maybe combination of RLC. Like that, if you are having in one of the upcoming chapters, we may use the terminology impedance. Okay, for generalized case, I have considered the word impedance. Similarly, if you want, say for example, if you are taking the ratio volta, that means current by voltage. In that case, admittance. Okay, so here I have given with respect to impedance, the same thing it will applicable with respect to admittance also. Okay, it is self-understandable. Okay, so in your free time, you can write similar point in your own words. Okay, right. Now all of you give a try. This is the MCQ, not MSQ. Okay, this is the MCQ question. Only one option will be correct. So up to previously, whatever the questions I have shown, MSQ, either one option or more than one option can be correct. Whereas this question is MCQ, only one option will be correct. All of you give a try. So here I am asking, choose the correct option. Choose the correct option. Only one option will be correct. All of you give a try. Any guess? Yeah, you can observe here, resistor is an example of bilateral element. Yes, it is correct. Yes, very good, very good. Diode is an example of unilateral element. Yes, that is also correct. Now just observe, since I have mentioned only one option is correct, Now you have to choose the option correctly. Okay, you have to choose the option smartly. Okay, so now read the option C. Both A and B are correct. Yes, this is the correct option. Option C is the correct. Since A and B both are correct, so the correct answer for this one is option C. Okay, now let us see. See, regarding resistor, I hope all it is clear for everyone. Okay, now let us see regarding the diode, how it is unilateral or why it is not bidirectional, okay, or bilateral. Say for example, when you are having the diode like this, okay, you are having two terminals 1 and 2, or otherwise you can call this is the P type, this is the N type. Okay, P terminal, N terminal, PN junction diode. Okay, when P terminal is connected, suppose polarity plus and N terminal polarity minus with respect to voltage, then in that case the diode is in forward bias. Diode is in forward bias. Okay, so if that whatever the diode I have considered, for the time being considered like ideal case. Okay, whenever the diode is forward bias, then equivalent circuit we can represent as short circuit. Equivalent circuit we can represent as short circuit. Between terminals 1 and 2, okay, here we are representing as short circuit. Whenever you are having short circuit, okay, since it is in the forward bias, I am representing the resistance R suffix F. F stands for forward bias. Now can you tell, whenever you have shorted two terminals, what is the resistance value? Any guess? Resistance value how much? Yeah, whenever terminals are shorted, the resistance value will be 0. Okay, this is for ideal diode. Okay, if you are considering practical diode, in that case you will be having, see, since you have connected polarity, voltage polarity plus here and minus here. Okay, because of that the current will flow like this between 1 and 2, and the current that is flowing between terminals 1 and 2, that is nothing but forward current, because the diode is in forward bias. Okay, so for practical applications, IF you will be having in the order of milliamperes. Okay, whereas forward resistance you will be having in the order of ohms. Okay, right. Now let us change the polarities of voltage. Suppose if you have changed the voltage polarities, then in that case what happened? The N terminal is having high voltage when compared to P terminal. That means the diode is in reverse bias. Okay, if you are considering the diode is ideal, in the reverse bias, the diode acts as open circuit. In open circuit, now can you tell what is the resistance value? In the open circuit, what is the resistance value? See, here we are telling there is no current flows. It is the ideal case 0 ampere, right? So that means ideal case the resistance I am asking, that means infinity. Very large value, right? So this is for ideal case. Whatever here I have mentioned, this is for ideal, okay, with respect to diode equivalent. Okay, similarly whatever the case here I have written, that is the practical. Okay, so in this case what will happen? The current will flow from terminal 2 to 1. Because terminal 2 is having high voltage when compared to terminal 1. Okay, so in the practical applications, that time the current flowing between terminal 2 to 1. Okay, since it is in the reverse bias, I am labeling as I suffix R, I suffix R. Okay, so I suffix R, that is a reverse bias current that is flowing through the diode, will be in the order of microamperes or nanoamperes. Will be in the order of microamperes or nanoamperes. Okay, so coming to the reverse bias resistance, it will be in the order of mega ohms. Now just observe. Yeah, all of you are getting correct answer for this question. I am appreciating everyone. Yeah, all of you are getting correct answer. Option C is the correct one. So now just observe with respect to this definition, regarding bilateral and unilateral. Okay, so just observe, an element is said to be bilateral if it offers same impedance for different directions of current flow. Otherwise it is said to be unilateral. Okay, so whenever any element, whether it is bilateral or unilateral, if you want to justify or if you want to identify, one method is you can give the voltage polarities. In case 1 plus minus here, in case 2 minus plus, like that. That is one approach. And one more approach is with respect to current. Okay, suppose in case 1 current is flowing like this, in case 2 current is flowing like this. Okay, like that also you can analyze. Ultimately the ratio of output and input, in this case, since we have considered voltage and current, accordingly impedance. Similarly, if you are considering current and voltage, it will be admittance. Okay, right. So now just if you observe, in case 1, ideal case if you consider, RF equal to 0 ohm. Okay, so here resistance is nothing but voltage and current, ratio of voltage and current. Similarly here resistance is nothing but ratio of voltage and current. Okay, in case 1 you are getting 0 ohm, in case 2 you are getting infinite. Whether both are same? Both are not same. That's why it is the unilateral element. Okay, if both are same, then we will say it is a bilateral. Okay, or even you can observe here, suppose in case 1, if the current in the order of milliampere is flowing, whereas in the case 2, order of microampere or nanoampere is flowing. So both the currents are not same. Okay, so in that way also you can correlate. Okay, because you have given the same voltage, but you have changed the polarities of voltage. Okay, so I hope all of you are getting the clarity how the diode is an example of unilateral element, or why the diode is not example of bilateral element. Here the word lateral or direction, both are same. That refers to the direction of current. Okay, so you can observe the previous example. Here with respect to this element. Okay, so here in case 1 and case 2, if you observe, the same current is flowing magnitude wise. I mean to say magnitude wise. Like say for example 1 to 2, here the current I is flowing. Similarly 1 to 2 minus I is flowing. But magnitude wise when you have considered, here the current I is flowing. Here also the current I is flowing. Okay. So if the element is bilateral, okay, the same magnitude of current flows through that particular element. Whereas if it is unilateral, the magnitude if you have considered, here in this case both are different. Here you are getting in the order of milliampere, whereas you are getting in the order of microampere or nanoampere. Both are not same. Okay, so this conclusion point you can note down. Yeah. So with that understanding, now you can guess this one. This is the conclusion point, whatever I have discussed with respect to the bilateral element and the unilateral element. Now all of you just fill this blank. All of you can fill this blank. This is the conclusion point, whatever so far we have discussed. Yes, I hope all of you can answer. It is bilateral. See here, an element is said to be bilateral if the same magnitude of current, that is very important, same magnitude of current flows through it for different polarities of voltage. Different polarities means case 1 you have considered plus here, minus here, and case 2 you have considered minus here plus here. In both the cases, magnitude of current if you are getting same, that means it is a bilateral element, otherwise it is unilateral. So up to here we have discussed with respect to active and passive, and then linear, non-linear, and then bilateral and unilateral, right? So now one more classification is regarding lumped and distributed. Okay, it is very simple. Whatever resistor, inductor, capacitor, okay, whatever the values you are having, say for example resistor value is like 5 kilo ohm, okay, say for example resistor value, example I am telling, 5 kilo ohm, inductor 5 millihenry, capacitor 5 microfarad. Suppose example I have considered, whenever you are using in any experiment, if you are using 5 kilo ohm resistor, 5 millihenry inductor, 5 microfarad capacitor, so that means whatever the resistance value, inductance value, capacitance value, that is fixed. That particular, whatever the material you have used, that particular material is behaving like resistor or inductor or capacitor, and the corresponding values like resistance, inductance, capacitance, those are fixed. Those are not varying with respect to length. Then we can call those are examples of lumped elements. Those are examples of lumped elements. Whereas when you are studying transmission lines in the EMFT subject, electromagnetic field and theory, right? Electromagnetic field theory subject, when you are studying, there you will be studying one of the chapters, transmission lines. Okay. So when you are studying transmission lines, that time you will be having like this. So here you will be having per meter or per centimeter, like that you will be having. So here what is understanding? Whatever the transmission line you are having with respect to length, that particular value is getting distributed. Okay, so that's why these are examples of distributed elements. Okay, so I hope all of you are getting the clarity. Whatever the resistor, inductor, capacitor, if those values are finite, if those values are not varying with respect to length, then those are examples of lumped elements. Whereas the corresponding values are varying with respect to length, then those elements we are calling it as distributed elements. Okay, regarding the distributed elements, you will be studying in the EMFT subject. Earlier I have given one way. Whatever the network theory subject concepts you are studying, with the help of that, you people can solve the questions of analog circuits whenever you are using with the help of nodal or mesh or with the help of any theorem, while you are solving the equivalent circuits with respect to transistors, op amps, etc. Okay, or regarding the characteristics whenever you are calculating with respect to voltage gain, current gain, input resistance, output resistance, etc. There are so many calculations you will be doing with respect to analog circuit subject. In most of the calculations, the network theory subject is a basis. Okay, that I have told earlier. Right. Now I am giving one more way. Okay, whatever the network theory subject concepts you are studying, with the help of that, when you are studying the EMFT subject, okay, so this is the basic subject, this is the advanced subject. Okay, or you can say that whatever the, say for example, in one of the upcoming session, we will be studying Ohm's law with respect to our network theory subject. The same Ohm's law you will be studying in the field theory subject, EMFT subject also. Okay, I will give the correlation. Whatever the Ohm's law you may study in the EMFT subject, that may be different. Whatever the Ohm's law that you may be studying in the network theory subject may be different, but I will discuss the proof of that one. Whatever the formula you are studying in the EMFT subject, from that Ohm's law I will derive and I will give the Ohm's law that we are studying in the network theory subject. So that means we can say that network theory subject is a subset of field theory. Okay, so whatever the resistor, inductor, capacitor, all those values are fixed. Okay, with respect to length, those are fixed up to some frequency. Say for example, up to 1 megahertz. Up to 1 megahertz. So these values are fixed. Those values are not varying with respect to length. But when you are going beyond 1 megahertz or 1 gigahertz, that time these values are varying, are distributing with respect to length. That's why you will be studying, okay, for understanding those components behavior, the network theory concepts we should not apply, rather we have to apply field theory. Okay, I hope all of you are getting a glimpse of this particular subject, how much importance regarding this particular network theory subject. If you are good at network theory subject, you can perform well regarding analog circuit subject. Even if you are good at network theory subject, you can perform well in the EMFT subject. Okay, in this way, when you are linking the subjects, when you are learning the concepts from very basic level, you can enjoy a lot while you are studying the advanced subjects. Otherwise, you may get bored or you may face so much difficulty while understanding those concepts. Okay, right. Okay, so that's all regarding today's session. I hope all of you got the clarity, whatever the terminology we have introduced in this particular session, right? So in this particular session, we just started with the basic terminology regarding the network and circuit. Okay, so with respect to study point of view, you can consider network and circuit as synonymous, but as for interview point of view, there is a slight difference that we have covered in this particular session. That is a very, very interesting and important interview question. Okay, all of you should have that knowledge, basic knowledge. Okay, what is the difference between network and circuit, whether both are same or whether both are different, or if they are different, what is the condition or what is the difference. Okay, and then we have introduced regarding the first chapter. In the first chapter, we have introduced the types of network elements. In this particular session, we have just learned the concepts. Okay, what is the classification, what is the difference. Okay, that much we have learned. In the tomorrow, we are having the next session regarding network theory subject. Timings are same. Timings are same. So we are having network elements part 2. Okay, same 4 to 5 we are having on tomorrow in our YouTube channel. Right. So in that session, I will be discussing whatever the classification we have introduced in this particular session regarding that characteristics. Okay. So I will be giving few graphs and all. Okay, I will draw the characteristics with respect to voltage and current. From there, you people have to identify whether it is active or passive or linear, non-linear, or bilateral or unilateral, etc. Okay, and then we will discuss with respect to resistor what are the various basic formulas we are having that I am going to cover in tomorrow's session. Okay, so I hope all of you got benefited from this particular session. Okay, so all of you can share your experience in the chat, and whoever watching this particular session later, okay, you people can share your experience in the comment section. Okay, so and after watching this particular session, okay, whoever getting benefited, so all of you kindly share this video link with all of your friends so that they also will get benefited from these sessions. Okay, and based on the possibility, try to attend these sessions in live, and due to any reason if you couldn't attend the session live, no issue, whatever the live session happening, that live session will be available even after the session over. That video will be available in our IMS Gate Academy YouTube channel, right? So you people can just visit our IMS Gate Academy. Okay, in the YouTube channel, just type IMS Gate Academy, and whoever just joining very first time, you people can subscribe our channel and click on the bell icon so that you won't get even single video. Okay, you will be getting the notification whenever upcoming live session is there. You will be getting the notification so that you people, based on the time possibility, you people can attend the respective session as per your branch. Okay, and as I mentioned earlier, so whoever not yet joined regarding our Telegram channel, so kindly join. Okay, whatever the important links are there regarding Telegram channel or regarding live online program for Gate 25-26. So all the links are available in the description of this particular video. So all of you kindly open those links, and whoever not yet joined, so kindly join our Telegram channel, and whoever not yet subscribed our YouTube channel, so kindly subscribe. Okay, and all of you kindly share the valuable information regarding Gate live program at our IMS Gate Academy. Okay, so this is all about today's session. We'll meet you all on tomorrow. So thank you everyone.